Making salts, a chemistry required practical. The aim of this practical is to prepare a pure, dry sample of soluble salt from an insoluble oxide or carbonate. A bit of background chemistry knowledge we need to remember is that when an acid reacts with a base, the products of the reaction are a salt and water. We will be using copper 2 oxide, an insoluble base, and adding it to sulfuric acid. The experiment will involve a neutralisation reaction to first produce an aqueous or dissolved salt. To then produce a dry sample of this salt, we need to remove it from the solution, which will be done by evaporating the water off from the solution. You might already be able to work out the reactants and the salt that will be produced. Some important safety points for this experiment are that goggles must be worn throughout to avoid chemicals, especially the acid, from splashing into your eyes. You need to be aware that sulfuric acid is an irritant. Copper 2 oxide and copper 2 sulphate are both harmful, and we must be sure to follow regular safety procedures when using Bunsen burners, and be careful handling hot beakers of solutions. The equipment needed for this practical include 1.0 molar dilute sulfuric acid, copper 2 oxide powder, a spatula, measuring cylinder, glass rod, and 2 at least 100 ml beakers. We will also require a Bunsen burner, tripod, gauze, and heat-proof mat. Finally, we will require a conical flask, filter funnel and paper, water, and evaporating basin. The first part of the method requires us to use a measuring cylinder to measure 40 centimeters cubed of sulfuric acid into a 100 centimeter cubed beaker. The beaker is then placed on a tripod and gauze set up on a heat-proof mat. A lit Bunsen burner is placed beneath it, set to the blue flame, which is the hottest flame, to heat the acid carefully and gently for about 30 seconds. Be careful here not to knock over the tripod or the beaker on top of it while it is heating. Remember, to draw a diagram of this setup, you are not expected to draw a graphical drawing, but use standard simple diagrams to draw each piece of equipment. The Bunsen burner is represented by an arrow pointing upwards from the word heat, for example, to make it simpler. When the acid is hot enough, which is just before it starts to boil, carefully remove it from the heat. Then use a spatula to add small portions of copper 2 oxide to the beaker. Stir the mixture gently for up to half a minute after adding each addition. You should notice a colour change in the solution as the base, copper oxide, starts to react with the acid. You should recognise that this reaction will produce a soluble salt, copper sulphate. That gives the solution a deep blue colour. We want to ensure that we add an excess of copper oxide, so adding more than is needed to neutralise all of the acid. We will know we have done this enough when we see black solid unreacted copper oxide within the solution. This shows us that the acid has been fully neutralised. We now need to try and remove any unreacted copper oxide from the solution using filtration. Take a piece of filter paper and fold it in half twice before opening it out into a cone and placing this filter paper into a filter funnel. Then position the filter paper and funnel on top of a conical flask and pour in your solution. This will filter the solution and remove any excess copper 2 oxide. The filtrate you'll be left with is copper sulphate, and the residue, the unreacted copper oxide. Again, we can represent this as a simple drawn diagram. After filtration, pour the copper sulphate solution into an evaporating dish. Place the evaporating basin on a beaker of water and heat using a Bunsen burner. The steam produced by the water will gently heat the solution. We want to avoid directly heating the solution, as this can cause the copper sulphate crystals to decompose and produce harmful gases. Stop the heating once the crystals start to form. And remove the crystals from the dish onto a dry piece of filter paper. Leave here for about 24 hours to dry. Once you've done this, you will see your blue copper sulphate crystals formed on your piece of filter paper, and you will have produced a pure, dry sample of solid copper sulphate salt. The salt we have produced has a chemical formula of CuSO4. We can see that the positive ion, copper, has a 2+ charge. And we could have got this copper ion from using the metal itself, copper. However, it's not very reactive, so probably wouldn't work very well. Using the metal oxide, so copper 2 oxide, which is what we did use in this example. Other sources include the metal hydroxide, copper hydroxide, or the metal carbonate, copper carbonate. So we can see how this method may be altered using different reactants. The negative ion in this salt is SO4, 2-, and the source we used for this was the sulfuric acid. To recap, this practical used a neutralisation reaction between an acid and a base. The acid we used was sulfuric acid, and it was neutralised by the base copper 2 oxide to form the products copper sulphate and water. You should be able to write the word and symbol equation for this reaction. Pause the video now to see if you can write out the symbol equation with the state symbols. Here is what the symbol equation should look like. H2SO4 plus CuO gives you CuSO4 plus H2O. You will notice that copper sulphate, CuSO4, has an aqueous state symbol, and this represents the copper sulphate solution before the evaporation step in the practical. After the evaporation step, when you've dried your crystals, it would be correct to say that the symbol equation then changes its state symbol to a solid. If you enjoyed this video, make sure you give it a like. And if you have any questions, leave a comment below. Check out more of our content and remember to subscribe to our channel.